so this is the 5th period video. We'll start with number 20 and do every third one till the end. 23, 26, 29. And again, the other videos are posted so that you can find them as well. Number 20. The graph of f prime, so this is f prime, which consists of a line segment and a semicircle, is shown on the right. Given that f of 1 equals 4, find f of 5. Okay, so I've got f prime, and it's asking me questions about f, so I think I want to antiderivative the derivative to get back to something with f. But as usual, I have to think about the limits involved here. But 1 and 5 are the x values involved in this problem. So 1 to 5, f of 5 minus f of 1. So this one is an area problem. So the area under the curve from 1 to 5. F of 5 is what I'm looking for. F of 1 is 4. So f of 5, if I move the 4 over, 4 plus the area under the curve. Okay, from 1 to 5. So from 1 to 5, is this area. Okay, so that's like a, what is that? Like a rectangle minus a half a circle? That's the only way to get that, is the rectangle minus a half a circle. So the rectangle is 8. 4 times 2 is 8. Minus half a circle. Pi times r is 2, so 4. So 4 plus 8 is 12, minus 2 pi. And you can see that 8 minus 2 pi, that's the area, but that's not what we're asking for. We want the area plus that initial value of 4. Again, if you're looking at like how I labeled things on the review or the test outline, that's a fundamental theorem of calculus type question, meaning the antiderivative of a derivative gets you back to the original.
Where does the 4 come from? Like if it's not asking for the ratio, what is it?
So this 4?
Yeah.
That 4 came from, it told us f of 1 was equal to 4.
Where is it on the graph? Is it part of the shape?
It's not part of the graph.
It's not?
Yeah, that's not part of the graph.
Okay.
That's a good question. That's not on the graph.
Where's the rectangle?
So this weird shape down here is like the rectangle minus the circle. Remember doing these in geometry where you had to find, like the area of something goofy like that, like the shaded area, that kind of thing. That's what's going on here. So the rectangle is this rectangle. So the orange rectangle minus the missing half a circle. Will give us the leftover stuff. Other questions on that one? 23. Oh yeah, 23. These are the ones they're not too bad if as long as it's matching, right? As long as it's multiple choice. If you have to write your own, which you won't, and you won't have to, those would be kind of a pain. But number 23, trying to match up which one of these things is the same thing as this. And so probably the first thing I'm looking at is from 3 to 9, that width is equal to 6. Uh-oh, that didn't help. They're all 6. All right, that's the first thing I'm looking at, is make sure their widths are 6. Next thing I'm probably going to look at is start at 3. Start at 3. Start at 3. Okay, so I'm down to B or C. I need to look at just which one of these matches the function 5x squared minus 8. 5 input squared minus 8. So which one is it, B or C? B. What would make C correct? How would you change this integrand to make C the right answer? 8x. Yeah, if that was minus 8x, then this would belong there, but it's not supposed to be there. So yeah, it's B. While our brain is sort of thinking along those lines, why don't you try number 24? Alright, so 24 was D. Number 26. The graph of f is shown. Let g be the function defined as g is the antiderivative of f. At what value of x does g have a relative maximum? Okay, g has a relative maximum when g prime, again I'm answering in like generically before I go to this particular problem, g has a relative max when g prime changes positive to negative. Okay, so I need something about g prime, and this graph is of f, so I don't know if that's helping me yet anyway. So there's what g is. If I take the derivative of both sides, the left side's easy, that becomes g prime, that's what I'm looking for. The right hand side means I need to take the derivative of the antiderivative of f of t dt. And then hopefully you realize, wait a minute, that's the whole point of this unit, is the derivative of the antiderivative cancels each other out, and we're back to f of x. And so they told us this was the graph of f, but they were being sneaky because that's also the graph of g prime. Okay, now I know what I'm looking for. G prime changes positive to negative at 1 and nowhere else. Right, at 3 it changes negative to positive. At 6 it gets to 0 but doesn't change. So yeah, only at 1. Number 29. Again, I don't know how to hint you any better than this. This is really similar to the test free response question. They give you a picture and we ask a whole bunch of questions about it. 28, 29, 30 are all the same type of problems. 29. The graph of the function f consisting of 3 line segments is shown on the right. G of x is, okay, this is kind of like what we just did. Find g of 2. Okay, that means plug in 2 for x. So g of 2 means the integral from 1 to 2 f of t dt. So the area under the curve from 1 to 2. Let's see here. It's a trapezoid, but I don't want to do trapezoids. I'd rather just do that rectangle plus the triangle, 1/2 base times height. So that total area is 2. Yeah, trapezoid would be the average height. The average of 3 and 1 is 2 times the width is 1. Yeah, so trapezoid would give me a 2 as well. G of 4, so the integral from 1 to 4. Okay, so I've got 1 to 2. Now I need to go from 2 to 4. 1, 2, 3, 4. Oh, well, That's a positive 1/2, and that's a negative 1/2. So from 1 to 4 is also 2. Because I guess on the net, I didn't add anything going from 2 to 4. Right? I added a 1/2 and then I subtracted a 1/2. And then lastly, g of negative 2. What's not right, or what feels weird about what I wrote here? I need to swap it. I mean, I didn't write it backwards. I wrote what I'm supposed to write. But if I want to find the area, I need to go from negative 2 to 1. And the price for doing that is to put a negative out front. So, small, worthy price to pay there. Okay, let's see. So this 1/2 base times height. Base is 3, height is 3. Oh, it just looks weird because it's not, the scales aren't the same. So 1/2 times 9 is 9/2. Negative. I did that last period too. Like, I made a big point about putting the negative out there, and then I forgot to include it in my answer. All right, part B. G prime of 0, 1, and 3. Well, G prime then, take the derivative of both sides. The derivative of the antiderivative is just f. So if I want G prime of 0, that's the same thing as f of 0. So I can look at my graph of f. What's f of 0? 2. I'm just reading it off the graph. G prime of 1 is the same thing as f of 1. So that's 3. G prime of 3 is the same thing as f of 3. So that's 0. Whoops, I said 0 and wrote 3. Struggling today. No.
How do you know that it's g prime of x equals the graph of it?
Because they gave me this, and I want g prime, so I take the derivative of both sides to get g prime.
Oh, right.
And then the derivative of the antiderivative gets me back to f. Part C. Find the instantaneous rate of change of g with respect to x. The instantaneous rate of change of g. So what's that asking for? That's a lot of words. That's just g prime. So that's making sure you understand the words. So g prime at 2, but we already said g prime is the same as f. F of 2 is 1. Well, that wasn't a hard one. It's just understanding the words. Man, I said it was 1. Do what I say, not what I do, right? Part D. Find the absolute maximum value of g on this interval. So absolute and interval means I better be thinking about a table of values. I definitely want to include negative 2 and 4. And any critical points would be where g prime equals 0. But g prime is the same as f, so the only place that happens is at x equals 3. Okay, did we find all of these already? G of negative 2 is negative 9/2. G of 3 we did not find yet. I'll have to find that one in a minute. G of 4, where did that one go? Is 2. G of 3, that's the integral from 1 to 3. So So from 1 to 2 was 2, and from 2 to 3 was a half, so 2.5. Not enough space on that one. Okay, but I haven't answered the question yet. What is the absolute maximum value? Okay, so is it, I know you're looking at the right thing. Now, is the answer 3 or is the answer 2.5? Okay, that's one way to, the real answer is 2.5. That's the absolute maximum. It happens at 3. But it didn't ask us that. The absolute max is 2.5. And again, you could say at 3. A lot of times it asks for it. But just so you know the difference between what it is versus where it is. What is the max versus where is the max? All right, part E. The second derivative of g is not defined at x equals 1 and x equals 2. Which of these values are x-coordinates of points of inflection of the graph of g? Okay, point of inflection. G has a point of inflection when g double prime changes signs. Yeah, G has a POI when g double prime changes signs. Well, I know that g prime is f of x. That we knew way up there. G prime is f of x. So if g prime is equal to f, what is g double prime equal to? Good, I heard both things. F prime, which is the slope of f. And so now I know why the second derivative is not defined at 1 and 2, because there's a cusp there. At 1 and 2, the slope of f is not defined. So g double prime is not defined. Now, which of those places does f prime change signs? At x equals 1. Again, one of the test questions on Wednesday is very similar to 28, 29, and 30. We give you a picture, and we can ask all sorts of questions about it. Maximums, minimums, second derivatives, points of inflections, increasing, decreasing, all sorts of things.